Hello, welcome to the 8th lecture in ML series. In this lecture, we will be discussing candidate elimination algorithm, which takes set of training examples as an input and finds set of all hypotheses which are consistent with the training examples. So let us quickly recap what we discussed in the last class. We have defined a version space, the set of all hypotheses which are consistent with the training examples, and a version space can be compactly represented by using a specific boundary and a general boundary. A specific boundary is a set of maximally specific hypotheses which are consistent with all the training examples. General boundary is a set of maximally general hypotheses which are consistent with all the training examples. Now let us try to understand this algorithm. So the candidate elimination algorithm, which takes training examples as an input and it finds a version space. That version space represents a set of all hypotheses, which actually gives S and G. S is the specific boundary and G is the general boundary. So initially we set G to the maximally general hypothesis, that is all question marks, and we'll set S to maximally specific hypothesis, that is all phi's. So initially we consider set of all hypotheses because in the lattice S is at the top and G is at the bottom, so which covers all hypotheses. Now by going through each example we have to remove some hypotheses. That's why it is named as candidate elimination algorithm. Okay, for positive examples, what it does is it makes the specific boundary more general. That means for each positive example, it will replace specific by minimal generalized version. That is, suppose if it has a phi is expected to say that no for always, but the training example is saying that it is true for a particular specific attribute value. Then hypothesis modified by setting that specific attribute value. And if the hypothesis is already having specific attribute value, but the original training example is true for some other attribute value, then as it is true for the previous value as well as the current value, then it will be replaced with any value, that is question mark. That means it moves from phi and a specific attribute value to question mark. That's about how we make the specific boundary more general. Similarly, for negative examples, we have to make the general boundary more specific. That means we have to replace with a minimal specialized. That means when you have all question marks, as it is expected to give true always, now it has to be, so to satisfy a negative example as well as the positive examples in the data set, you replace with a minimal specialized with some specific value for the attributes such that they will be satisfying both positive and negative examples. Now we will try to understand this one on this example, the Enjoy Sport data set. So this data set has 4 examples. The third example is the negative example. Remaining all are positive examples. Okay, so we will be processing in this order 1, 2, 3, 4. So first, for the first example, as we know that initially your S is all phi's and G is all question marks. So G is all question marks. As all question marks is consistent with the example because it says for any value it is true, even it is true for sunny, warm, normal, strong, warm, same. What about the specific boundary? A specific boundary is saying that this hypothesis is false, then we have to replace with a minimal generalization. So that means phi has to be replaced with the actual value of the attribute, that is sunny, and similarly air temperature is replaced with warm, so on. Then we get a specific boundary. Now with this S is consistent with the first positive example. Now let us consider a second example. When we consider the second positive example, G is having all question marks. That means it is saying that true for any values. So it is consistent with the, even for a sunny, warm, high, strong, same, warm, same. Now consider a hypothesis in S1. Now hypothesis in S1 is saying that humidity must be normal. But the training example is saying that it is true even for humidity high. So what it means is humidity high it is true, as well as humidity normal is true. That means we can say that for any value of the humidity it is true. So that means it has to be replaced with a question mark. So we will get a specific boundary as sunny, warm, question mark, strong, warm, same. This is for the second training example. Now let us consider the third training example. Third training example is a negative example. As the specific boundary is already satisfying this, because here sky condition is sunny, then only it should be true, but it has rainy, so it returns no. That is what we are also expecting here. But you consider all question marks. All question marks is a hypothesis which says that whatever the values, it should give a yes. But we are expecting a no for a rainy and a cold, high, strong, warm, change case. So now we have to modify this G. Now for that, consider each attribute. Now we have a sky. Sky, rainy, it should give a no. So we will consider the minimal specialization as sky, condition as sunny, remaining any attributes. Now if you observe, this one satisfies, because this one gives no for this example, because the sky condition is expected sunny, but here it is rainy. And this is one hypothesis. Similarly, we will consider a second attribute. Second attribute is air temperature. Now air temperature cold, it is expected to be give a no. So we will consider air temperature warm. So that is the minimal specialization. Air temperature is warm and remaining attributes can take any value. Now this satisfies a negative example as well as it satisfies the positive examples. Now consider a third attribute. Third attribute is wind speed. A third attribute is humidity. Humidity, when it is high, it should give a no. So we will consider normal. That means we will have question mark, normal followed by all question marks. But that hypothesis is not consistent with the positive examples, because even for the humidity high, as you can see in the second example, even for the humidity high also, it is expected to give a true. So that is not consistent, so that won't be added here in general boundary. Similarly, for the fourth one, wind speed is strong, so we consider wind speed as weak, and all remaining attributes can take any value, and that won't satisfy the positive examples. because in all positive example the wind speed must be strong. That's why that won't be added. And consider the next feature, that is water condition. Water condition is warm, so if you consider a water condition as cold, and remaining attributes as, that is the minimal specialization, but that won't satisfy positive examples, because in all positive examples the water condition must be warm. Okay. And next, consider the last attributes, that is the forecast same or change. So for change it should give no. So we'll consider a hypothesis forecast as same, and remaining attributes can take any value. That satisfies all the training examples. So now we will get a 3 hypotheses in the general boundary. Now let us consider the fourth example. When we consider a fourth example, now in the fourth example, if out of these 3 hypotheses in G, the last hypothesis won't satisfy, because here even when the forecast is changed, it is expected to give a positive result. So the last hypothesis won't satisfy. All question marks followed by same, that will be removed. Then we'll get a sunny followed by all question marks, warm followed by all question marks. It satisfies because this example is also having sunny as well as warm. And now so far in all examples we had the water condition is warm, then only it is expected to give a positive. But here it is saying that even for water is cool, he enjoys a water sport. So we'll replace with a minimal generalization, that is question mark, any value. And here also we have so far for any for the forecast same it is expected to be true, but even for the forecast change also the current training example is saying yes, so it will be replaced by the minimal generalization question mark. So at the end we will get these 2 boundaries, sunny, warm, question mark, strong, question mark, which is a specific boundary, and a general boundary is sunny followed by all question marks, and a warm followed by all question marks. Now, so, and in detail how it finds, with an explanation we have given in these slides, and you can check it later. Now the properties of this candidate elimination is, which if there is no noise, it is guaranteed convergence, and it finds all hypotheses which are consistent with the training examples, and it uses both positive and negative examples, and it also can detect the inconsistencies. When you have inconsistency, what happens is it removes either from a G or S, it removes all hypotheses. When one of them is empty, you can say that there is an inconsistency or noise in the training data set. Okay, so and the limitations are, it still works on a conjunctive concepts, that means and on some constraints on attributes, and or combination is, we cannot use this, and for that we will be using a decision tree. And it cannot handle unobserved attributes. All attribute values must be present, and sometimes it may result in the large version space. Okay, and sometimes as it is a large version space, and sometimes maintaining these G and S are computationally expensive. And with this our first unit syllabus is completed, and in the next unit we will be discussing regression.